Hello everybody. So let's take a minute to look at this problem from our assignment. And it's a problem where I guess I could say we're given some function about how fast oil is produced in barrels per day. And then from that, I am going to figure out some way to answer these questions about how many barrels are produced over different time periods. Okay. Um, so that's the scenario. And I guess like if I could just frame the broad question about what we have here is can we go from knowing uh, how many barrels are produced from how fast they're produced? Okay? If I could sum it up as simply as possible, this is what we're trying to do. I want to calculate how many barrels are produced from knowing how fast they are produced. Okay? So like I was saying, that's what q prime of t, this function that's given there, it's a piecewise function, see it right here, okay, is the instantaneous daily oil production. Q is barrels of oil, t is time in days, and so this function is telling us how many barrels per day are produced at any moment, okay, on any day. So for part A, which is this, how many barrels are produced in the first 35 days, okay, then the answer would be this definite integral. Okay, from day 0 to day 35, q prime t dt. All right. As far as a quick reason why this gives us what we want in part A, you could think of the integral this way. Q prime of t tells me what? Production speed, production rate in barrels per day. And dt I might think of as expressing what my variable is, which is t, which is measured in days. And if I took a number in barrels per day and I multiplied it by days, I would get barrels. And that's what I want, right? I've taken this function about how fast the production is, barrels per day, and by way of what this integral does to assimilate these things together, I'm going to get barrels, how many are produced. All right. I'll say more about this in part C, but I think that's a quick way to understand why this is what we want. There are all kinds of tools in math. And, you know, and I guess any of them are at our disposal to answer this question or any other. But I just want to say something real quick about why of all the tools available to us is the definite integral what we want here in part A. Okay, so that's what I want, and if I can evaluate this, I'll have my answer. As far as how I would evaluate this particular definite integral, I wanted to do it like this. Okay, so I am set out to calculate this definite integral from 0 to 35, from t is 0 to t is 35. But I noticed that this particular function that I'm given, that I'm working with, is a piecewise function. And that means like whatever the formula that tells us our production rate depends on what t is. So it's not like it's just one formula. And for that reason, I don't think it's as straightforward to use the fundamental theorem of calculus to evaluate this definite integral. But there's this rule for definite integrals that say if I have an integral from a to b and c is somewhere in between a and b, then I can split that up into pieces. I can go from a to c and then c to b, solve those individually, and add them together. So I'll do that. I'll say, okay, I need to go from 0 to 35, okay? But I noticed that in pieces, this function's first piece is from 0 to 30, so I'll go 0 to 30. And then if I need to go all the way to 35, I'll pick up from 30 and go to 35 using the second one, okay? That way, like, I'm only using the first one as it applies up to 30. And then the second part of this as it applies from 30 to 35. And that takes me all the way to 35. All right, so the formulas respectively are 900, 0 to 30, 2600 minus 40t, 30 to 35. I used the fundamental theorem of calculus, find the antiderivative of each of these, evaluate, I'll get 33,500 barrels. So yeah, I have this function telling me how fast the production is in barrels per day, and then I can tell you how many barrels were produced. That was how I framed this original question, how fast to how many. So I'll let you do part B. I don't think that there's any real challenge to doing part B if I just showed you part A. It just goes up to the first 50 days. Okay, so it'd be this integral 0 to 50 q prime t dt, which I think you'll also have to split up into 3 pieces this time for part B. So something really grabs my attention about part C. So part C would seem like just more of the same thing if it weren't for asking me to solve it without calculus, okay? And I guess if we try to solve C without calculus, it might show us or a way to understand when and why calculus is sometimes needed, okay? So if I can think of some way to do C without calculus, I think it'd make for a good comparison, all right? And like I can say a little bit more about the way this integral is set up to get what I want in the first place. All right, so I want to know how many barrels are produced from day 70 to day 80. That's what it said. It didn't say it in exactly that way. It says produced over the interval 7 to 80, but that's what it means, okay? Without calculus. Now, I want to analyze this formula a little bit. I haven't really talked about it yet. I told you it was a piecewise function, but I didn't look at each part of this and think about what it told me. Now I'll do that. And I think through that, I'll discover why calculus is not needed. So let's take the second one, 2600 minus 40t. So what that tells me is that from day 30 to 40, the production is not constant. Like what this tells you in barrels per day for the production rate is going to be different on day 30 than it is day 31, than it is day 32. Like you're going to get different answers when you put in different values of t. That's just the nature of that formula. You could even say further that you'll find that production is decreasing by 40 barrels per day from day 30 to 40. So it's not constant. All right, production is not constant within that time period. But what about this last one, 400? That doesn't say 400t, it just says 400. So from day 40 onward, production is constant. It's 400 what? 400 barrels per day. So I think it is entirely because it's not changing. The rate is not variable. The rate is constant, that we don't need calculus. Think of it like this. So from day 70 to 80, I can make the inference that production is constant at 400 barrels per day, right? And if you're producing oil at 400 barrels per day for 10 days, that's 10 days, right? From day 70 to 80, sure. 10-day period, constant production, 400 barrels a day. You just multiply those together and you'll get 4,000 barrels, okay? So it's kind of like distance is rate times time if the rate is constant. If I go 60 miles an hour, constant rate for 2 hours, well, 60 miles per hour times 2 hours, that's 120 miles. You just multiply distance as rate times time. If the rate wasn't constant, say I was speeding up or slowing down, well, then I wouldn't just multiply distance as rate times time. So it's, I guess, when our rate is not constant that we need the integral. So see how we're dealing with the same kinds of things? I get barrels per day times days, and then I'll get the total production. If the rate is constant, I'll just multiply them together. If it's not constant, it's like in the integral, I'm still multiplying them together. But the calculus comes into play to account for the fact that the production is not constant. Okay? The integral takes care of it from there. But do you see the similarity between these? All right? Okay, so they really are similar in that respect. Now, from here, like I wouldn't need calculus if I had a constant rate of change. Okay, I could do something like distance is rate times time, like this. And otherwise, we have calculus, we have definite integrals for dealing with rates that aren't constant.